And I've got that pretty much squared away. Take a couple of sheets of nylon towel. Got a little pitch on this also, just when I put it away in storage, it just kind of got some pitch. Take the top off, I had not put the top back on fully. Pour out a little turpentine onto the top of the mirror. This time I'm going to take another couple of pieces of towel. Rub it off, just rub off the pitch. Get it nice and clean all the way around. Work the edges. This Googles comes right off when you use turpentine on it. I want to clear up the blank really well. Look inside. It's a nice big bubble, probably 2 millimeters. Looks like it's most of the way down. Casts a bit of a shadow on the newspaper underneath. Beyond that, there's nothing too terribly seriously wrong with this glass. It's a nice piece of glass. So it's going to make a great substrate for a mirror. And remember, what we're working on here really is not a mirror. The mirror is the thin coating of aluminum that's going to be melted onto this thing or electrolyzed onto this thing when it's all done. Right now, this is just the substrate to hold the mirror. But making the substrate is where all of the work is involved. And I'm going to just go around the edges and move this out of the way of the camera a bit so you can see. And now I've spent a little time this evening working on my telescope. I've got a military obligation this weekend, so I'm not going to be able to spend as much time as I'd like on it. Maybe I can spend a little time. Today is, I'm going to close this top. Today's Friday, August 14th, 2007. And it's in the evening, a little bit after 7 o'clock at night, 7:08, 7:09 right now. Have a clock here. Clock's a good thing to have in a optics shop, just to keep track of how long you're doing things. I can't recommend it highly enough. Now I've got this glass pretty clean, really clean. Now what I'm going to do is just move the turpentine aside. Move the brushes aside. Remember, I'm going to throw this out especially. I'm not going to leave this lying around the shop. I'm going to take this glass off the top also and just put it aside for a few minutes. I can actually put it over by a tool, that's not a problem. I bought some microfiber towels. What I'm going to do is I'm going to take this large journal off the top of the table that I had built. Put this with the paper towels. I'll put this all aside for a few minutes until I'm ready to take it outside. It's all got some turpentine in it. The underlying surface I've cleaned off. It looks terrible, but it's really pretty clean. Take these microfiber towels, take a couple of them. One. Two. Oh, sorry about that. There's three. Take one more. Make that four. Put them on top of the table. Take my mirror or my substrate. Put it down on top. These microfiber towels are great things. You buy them at any auto parts store, relatively cheap. Which is good because I'm a relatively cheap kind of guy. I just need one on top. And I've got it covered. That's it for tonight. I'll be back again hopefully over the weekend, unless I wake up at 3 in the morning and can't sleep. And we'll be melting pitch fairly shortly and putting it on the top of the mirror and then pouring the pitch lap and getting ready to go from there. Until then, good night. Good evening and welcome back to our telescope making workshop. I'm Francis O'Reilly.
And I'm Elizabeth.
And she's my daughter. And this is Seamus's cat. We got together tonight. We've just decided to heat up some pitch and see how it's going, to see what the characteristics are. One of the things that I'm doing here that's probably wrong is I haven't poured a pitch lap in many years, and so I'm going through excruciatingly slow preparation before I actually melt and pour the pitch lap. It's probably not necessary. But in any event, we're not going to do it tonight. We're hoping we can do it tomorrow. Elizabeth is also working on a 4.5-inch mirror, and she's gotten through rough grinding, has ground out her F10 curve, and is now working on fine grinding. She's gotten through 330 carborundum, silicon carbide. And the next step for her is going to be about a half hour at number 500 before she moves on to the aluminum oxide grades, 22.5 micron, 15 micron, 9 micron, 5 micron, and actually she's going to go down to 3 micron before we pour a pitch lap for her. And she's going to spend about a half hour with each different grade of abrasive before she moves on to the next, just to get out the pits. With larger mirrors, you may want to spend more time, 45 minutes to an hour, and actually when I was grinding an optical flat, I made sure that each specific 7-inch surface, and we actually worked 6 surfaces, 3 discs at both sides, each surface had an hour of glass on glass time. So for right now, I wish you could smell what we're smelling. The pitch is getting pungent, and that's a good sign. We're going to sign off now, and hopefully we'll be able to record this our pouring and pitch tomorrow. So for now, Saturday night, August 15th, 2007, Elizabeth and I say good night. Well, it's still Saturday night, and Elizabeth and I were talking, and we've reconsidered what we're going to do. We've got plenty of time this evening, not much to do. And so we've decided that as long as we're melting pitch, we're going to continue to melt pitch, and we'll try to pour the pitch lap tonight. I had probably about 8 ounces of pitch in my can. I use paint cans that I buy from the Home Depot to melt it in. My wife is now coming downstairs. Come on down, Dina. And we're going to, she said no, we're going to melt the pitch, and then we're going to pour the pitch lap. And in the meantime, what we're going to do is prepare to do that. Now, I've got cerium oxide here in a little bottle. Not a lot, but you really don't need a whole lot of cerium oxide to do what we're going to be doing. I have some wax paper. I have, would you hand me that little green bottle, please, Elizabeth? I have a lap release. It's just a form of mold release that we'll put on top of our perfect pitch lap mold that we purchased from a firm that makes these, specializes in making these. Now, one of the interesting things here is that our mirror is a 12.5-inch mirror, but this lap mold is 12 by 12. You would say, well, how are you going to do that? Initially, that would be a legitimate question. How are we going to pour using that? And what we're going to end up doing is we're going to end up having a bit of an overlap, or an underlap, I should say, rather. But that's really okay, because you really don't need your pitch lap to go all the way out to the end of the tool. In fact, it's not necessarily desirable, and you're going to have a little bit of an offset. You really don't want to have the pitch lap correctly, or completely rather, symmetrical. You really don't want to have both seams crossing when you make your channels in the pitch lap. You don't want them crossing in the middle of the lap. You want them somewhat off-center. That way you avoid having zones in the mirror as you work with it. We've rearranged what we're doing here so that you can see more of what we're doing and less of us, although I guess you can still see all of us. And right now I'm going to just take a look over at how our pitch is melting, and it's melting slowly, which is good. You really don't need it to be melting all that fast. I don't turn the heat on real hot and heavy, I turn on the heat fairly slow and I let it warm fairly slowly. I don't want it to burn. Pitch, I always melt on an electric hot plate. I don't want to use open flame near it. Why is that? Well, pitch is a natural product. It contains a lot of volatiles in it. And if you keep it near an open